Hi, welcome to Go on the Run. We are looking at part 3 of binary encoding, and that means we're going to be looking at a little bit more of Protobuffer. In part 2, we did a little bit of intro into Protobuffer, and part 3 will go a little bit deeper. Now, I want to say a big thank you to all of you who watched my videos, who subscribed. If you haven't subscribed, please hit that subscribe button. We've hit 1,000 subscribers on the channel. To me, that's a huge milestone compared to people who have hundreds of thousands of subscribers or millions of subscribers. 1,000 doesn't seem like a whole lot, but for me, it is a lot, and I appreciate it very much. One of the things that I promised is that after a few months of putting my Go language course on Udemy, is that I'll make it available on the YouTube channel, and I'm still intend to do that. I've just been pretty busy. That's why I didn't get to post videos for a while, and I was on vacation. Got to take time out to rest also and recoup. So now I'm back. I'm refreshed, and so I'll get back to making videos. I'm posting them every 2 weeks, and I'll definitely work on, I have to do some editing on the video that is on Udemy and post it here. It's still going to be offered on Udemy, so if you feel like supporting me financially, feel free to do so either by buying the course or making a contribution to my PayPal account that I show at the end of the video, and I'm showing now. Feel free to use those ways if you feel like supporting me. Another thing I'll look into now that I've hit 1,000 subscribers is some sort of Patreon thing. I'm not sure exactly what that's going to look like. Usually people, when they do Patreon, they do things like, certain the Patreon supporters get to see the video a week or a few days before the other people get to see it and all that sort of stuff. I don't know if that quite will work for me and you, because I tend to record the videos, edit them, and then push them out. If I had a lot of time to really record the videos much earlier, maybe that would work. But right now, like I said, I still have a daytime job. All right, so let's get into today's material before this video is too long. What's on our agenda for today? We're going to be looking at nested type and enums. Now, there are other things that you can do, that like you can do any fields, you can do one-offs, which I will not cover. I'll give you my opinion on them a little bit later, but this is the documentation about everything, so feel free to read it, and you absolutely should. If you don't want to read it up front, definitely when you're ready to start working on a project, you should read it to see what's available. Maybe it might make sense for you to do things differently. All right, so what are we doing? Let's start off by picking up where we left off. So if you remember, in part 1, we look at GOB and doing binary encoding with GOB and showing how much more that efficient that was than doing our JSON encoding. And we showed that JSON was even more efficient in terms of the size, encoding size of a message, than XML. And then in part 2, we started looking at, and so we can fire up our editor to look at part 2. And in part 2, we sort of did this. We looked at how you can write a protobuf definition and then encode it, generate protobuffer definitions for different languages like stubs. And we looked at the output for Go, and we saw that it's basically a struct that's generated with our parameters. So even though we generated the parameter Q, which is a string, and params, which turned out to be a slice of strings, and our protocol definition for that was repeated string parameter, we didn't really use it. Our main .go code was sort of when we had the client request, which we replace with, the search request. So let's pick up from where we left off, literally from there, and continue. So what I'll do is I'll close this, and I'll say copy -R. I'll copy part 2, exercise 1, and I'll call it part 3, exercise 1. Right? Okay, main K directory part 3. Let's do that. And let's do this again. And there we go. All right, so let me clear my screen. I'll do code part 3. All right, so actually, maybe I can, Let's do part 3. Okay, so now that we have this open up, okay, let's modify it and see what we're doing for today. So let's get rid of all these excessive language that we generated for, because we really don't care. We just wanted to demonstrate that using profile buffer, we can have this simple definition and then we can generate for the different languages. So I'm gonna get rid of this. And so now that we have here, we have Q, which is a string for our message or search request message, and then we have parameters repeated. Let's update our main.go to show that this is just a rather simple structure. So if I do this and I do request string, and maybe what I can do is just, you know, create a new variable, save it like this guy, and then I do this and this, and let's say, for example, that what I want to do is my query, I want to set a query to the background to look for books, and the parameters I want to specify is a slice of strings, capital S, but rather lowercase s, and maybe let's put this on multiple lines so it's easier to read. So we'll do this. Let's save our file so it's formatted nicely for us. And so what are my parameters? Well, maybe I want to, if I'm paging through the results or the query, I might want to send to the backend the offset or what page I'm on or where to start from. So maybe that's offset 10. That's one of my parameters. Another parameter might be how many, or the limit, right? How many results I want to come back. And so maybe it's 100, for example. And maybe I want to also say that I'm only interested in books that were published on a certain year. So pub year, for example, is equals to 2019. So that's an example of how I can send a query and I can parameterize that query. And so if we print this out, this is not going to be anything too interesting because we already said that this is just basically a strut. And so let me go here on my part 3 and I can say go install, for example, binary encoding, and we want to do the model, so let's encode our model. So there we go. Let's go into exercise 1. That would help. And then I do this and I include my model, and let me clear my screen, and so run that again so you can see we install the model. So that's our latest model, and we can run our code. So go run, and as if I do command main.go, and so you can see that nothing exciting there at all. Okay, the only reason I wanted to run this example to show you is because the last time I showed you the protocol stuff, and I built it, but I didn't actually use it. So just wanted to do that. Okay, so the next example then, this is pretty straightforward. Like I said, we're literally picking up from where we left off the last time. So let's copy that and let's paste it. And I don't like how this new updated version of Visual Studio Code rename something when you paste it, but I have to see if there's a way to go back to the whole style of doing it. I prefer the whole style. So in example 2, let's look at our model and see what other new things we can do. So if you notice, we have this repeated string which says that we can have multiple parameters. Now the way I did the example is that I showed you how I could use multiple, even though params is a string, because it's repeated, I was able to specify multiple string, and that's what you see here. I have what looks like an array with multiple string values. But usually query parameters, you could think of them as a map of key to value. So Protobuf also have maps, and so we can change this from string to say this is a map of string to string, and you specify it this way. And so we could say parameter is a map of string to string. But because this is already a map, you're not allowed to modify it with, you know, something like repeated, like how you were able to do it for a string. And so what would that mean? If it was allowed, you'd have repeated map values. That would be nuts. So so map doesn't allow you to say repeated. And so that's sort of good enough for us. And so let's go back up and let's go to our exercise 2 directory. And let's go to model. Well, actually, we don't actually need to go to the model. We should be able to do, okay, let's go to model so we can actually rebuild our code. So you can say proto, and if you remember, we ran it this way before. And so this rerun, and we can generate the updated code. Okay. And if we compare this to, let's say, select this for compare, and then compare with selected, and we close this, we can see that not much has changed really. So this block changed, and it went from a slice of string to a map of strings, and this is in line with how you would do a map in Go. And so for other languages, it might be represented a different way, but we don't need to worry about this. All this is generated for us, and we can sort of ignore those specific things. All right, so let's go back to our code. To our where we want to do, let's make sure that we're dealing with the main from exercise 2. And so here, this should give us a message when we do go install. So we install our model, and if we go back up and we do go run and then cmd main, this should fail because we have a slice type and it's expecting a map. So we can certainly change this, and we can say this is a map of string to string, and these are our values. We can do tap, tap, and then dip, and then dip, and that should take care of it. Let me see. Yep, there we go. Error message goes away, and we can run this now, and there we go. We have map limits to thing. So again, very straightforward. All I'm showing you is the different types of things that Protobuf supports and how it maps to Go. Okay, because remember, we're doing all this because we eventually want to do gRPC and all this other stuff and be able to send messages. And if we have messages that are maps or values and so on, how do we send them? So that's why we're going through the pain of learning Protobuf this way. Okay, so let's copy this now that we know how to do maps. So we start off, we did repeated, now we did maps, and there might be time where you might want to use repeated, right? I'm just saying that for parameters, it makes more sense for this to be a map value. But if you were sending maybe somebody's phone number, and phone number was a string value, you might say, well, they have multiple phone numbers, and so several phone numbers, and so there might just be a straight up repeated value, which is going to turn into a slice in Go. Okay, and paste, and this is really super annoying. Exercise 3, and so let's go to exercise 3 and clear. And so maybe, all right, let's see. So exercise 3, so one of the things I mentioned is that Protobuf allows you to evolve your messages, and it does this by assigning these numbers, and that makes it super easy for new clients or new services to introduce new messages and still also be backward compatible with the older clients, because the fields are numbers, so you don't have to worry about them, and you're not allowed to reuse a number. So let's say we want to add a new field. If we want to keep this backward compatible, let's say the field we want to add is an ID field, so that every request we send to the server, we can uniquely identify that request, and that way if we happen to send multiple requests to the server and they don't come back right away, then maybe we can know which requests we're getting a response for and so on. So maybe we want to do an int64, and we want to call this an ID, and of course we have to give it a number. Now you might be tempted to think, you know what, why don't I just put this first, call this 1, call this 2, and just basically renumber everything? And you can certainly do that, just note how you're going to break your clients, the older clients. So when you have to add new fields, always make sure that you add them and increase the number and do not reuse numbers. Now you can also remove fields and say that certain numbers are reserved and no longer should be used. And I encourage you to read the Protobuf tree documentation to see how that can be done. Okay, so now our search request has a new message, but we have a search request, but this would be a message, for example, from the client to the server. But the server might also need to, the server need to send back a response. So we can define our search response message, RESP, and we can say, well, what does that look like? Well, since we're defining this now, we can certainly put our ID first. So yeah, there's nothing wrong with this. The numbers here are simply for Protobuf and how it generates and manages the field. But search request and search response are two different messages. And so the fact that I'm using ID in both really doesn't have anything to do with each other. I could choose not to have included the ID if I wanted to, or call it something else. I'm just simply saying that when we make a request with a certain ID, we can have a response with that value to know which request we're responding to. And since we're now defining our search response, we don't have to worry about backward compatibility. So we can call ID message field number 1. And also we would want to be able to say that we have a string, which is the answer to that request, which we can easily call field number 2. And so string. And so again, this is pretty straightforward. Note that we have multiple messages in the same protobuf file. And so of course we can certainly go to the model directory, and you know what, let's do it this way. If we go to this, and the output is equals to model, and I believe there's a minus include directory -i for model. So let's see if that works. There we go. And so if we look at the output here, we should see that we now have, in addition to our search request, we have this ID field, and that makes sense. And so we should also have a new field for our search response. We have ID and string. Nothing surprising here, so I'm not going to update our code to play with this because it's just a struct with some additional fields, right? So nothing exciting there, but I just want to show you that. Okay, so let's close this. And our fourth example, we're going to imagine that, let's see, so let's first grab our fourth example. So example, now that our server can receive a request, a number of requests, by the way, and respond to it. Maybe our server, when it responding to messages or is answering a query, it can pull the result from a number of places. Maybe it can use cache. You know, like if somebody else has made that request before, it can say, I have this answer cache, and it wants to tell the client that, oh, this response came from the cache, or maybe this was, you know, something that was current, right? And so what if it wanted to say where this answer came from? So we want to say from source, right? So where's the source of this answer? So we added another field. We're evolving our server here in our message. And so we call this 3. And what is this from? Well, from could be something like an enum, right? And so we can say from cache is equals to 0. And there's the thing with an enum, when you have these enum field, the very first field must be 0. And so you can say from cache, or this is current. And so now this would be a value that would be set on the response to let the client know that, oh, this answer came from one of these two places. Okay, and so what does this look like when we generate the Go code? Now remember, in Go we do not have enum. So what does this look like? So let's go to our example 4 directory, and let's rerun this, and let's take a look at what it looks like. So here we are, and if we scroll up, you can see our from enum is just a type defined on int32. And for people coming from languages like C or C++, enums are just ints anywhere. And so this is not surprising. There's an integer. And we can see that clearly from the assignment here. You know, you're just assigning a number. So enums must be some form of an integer. And then notice that we have these constant defined at from underscore. So essentially we have the values for our enum, or the different values, in a way almost parameterized or within the scope of the enum name. And so that's how this code is generated for Go, is that the enum name underscore and then the value, and these values are simply cast to this specific type that's been type defined. So these are type defined constants. You can have untyped constants, but these are type constants. Okay, and then we have some convenient methods to help us look up for this enum that's named from the names. You know, we can give it the number and get what's the string representation, or give it the string and get the numeric representation. Again, which is something that you can easily do in a language like C++ or Java. And so we have the string methods for that. So nothing really exciting. If we want, we can play with it. So I can say go install, for example, binary encoding package, and I want to do the model package. And so now let's see our example here. We can do what? So we already have a request, and so what else? Let's do the response. So server response message colon equals and model that, and here we go. We can see that we have all these types already. So let's do a response, and let's do ID. So let's do message 5, right? Let's put it on different lines so it's easier to read. And come on, there we go. And let's see, another type is another field is the answer, and I don't know what is the answer. Well, maybe it's some JSON response or whatever. We didn't specify what our answer should look like, right? Maybe our answer is a repeated field that's a slice of strings to say which books we're looking for. So maybe this is maybe a string, and it should be book 1 or something like that. Book 1, book 2. But since we did not say that our answer is a slice of string, we're not going to change it right now. So we'll just simply say that we're going to have a comma separated list of, or colon separated list of values to indicate the different book, book 2 or something like that, right? So you get the idea. I messed this up by not saying answer, how answer should be come back. Okay, and so that's that. I don't need that. And then the next field that we want to set is our source. And so where did we get this from? Is it the cache response? From what? And so we can say from model that from, and we can say from cache, for example, right? Or this is from current, right? If we didn't use a cache response. And I'll do this server response 1 server response, and so there we go. Let's build this and run again. So go run cmd main.go, and there we go. Right, not anything heart shattering to use this at all. If, as you can see, we use the value, and then when we print it out, we actually get with the string representation as opposed to some meaningless number like 1. Okay, so nothing exciting there. So let's move on. And so the last thing I want to do is talk about nesting messages. And so let's do this, copy and paste it. And once more, we'll do exercise 5. Let's close these. And so let's say, for example, so let me close this for now. And so let's say we have these messages defined, but we want to sort of encapsulate them or nest them, because maybe we have multiple other messages, and this from, we don't want to conflict with some other enum or message that we might have below that is also from. So one way we can do this is to wrap this in a message, and we could say message, this is our search messages, and we could sort of do it this way. And I will just move this to the end. So I'll drag this, plop it down at the end here. So I've wrapped here, and I don't have formatting for my Protobuf file. I don't know why. So let me just grab this and indent it so it's easy to see. Tab. Okay, so now I've wrapped my messages in these individual messages, not a message, and this is something you can do. Now for different languages, this would be implemented differently. For a language like C++, you can imagine this would be a namespace with a message, and if you had multiple nested messages, there can be namespace within namespaces. And for Java, maybe nested classes in Java, since you can have classes within class. So these would be inner classes, right? Like I haven't looked to see how it would be rendered in all those other things. In C, I don't know how exactly they'll pull it off. Maybe they'll do something like what they do in Go, which you will soon see. So since I have this outer message called message, and I have these outer message nested within them, it's kind of redundant to have search and then search request. So since we're talking about requests, this have to do about searching and response. So why don't I remove those? So this request have to do with search, and this response have to do with search, And this from is from a search source. So why I don't need to tack on search again. So that's all I've done is wrap the entire thing, my three messages, my three types, the message, the enum, and this within a message. And by the way, if we have this enum that only applied to responses, we could have take that out and I'll just move that within here, and we could have put it anywhere within there. It didn't have to be, you know, right there, but I'm putting it just above the type that the field that uses it. All right, maybe we get some space. Okay, so now what I have is my enum is scoped to the response message. My response message is scoped to the search message. So when it says scope, what I basically mean is basically if we had some other message outside here, we can still reuse these name, response, request, and from, because it would be outside of search. Now let's build it and see what we get. Let me open back up this terminal and I'll go back up and then to exercise 5. And then we want to run our proto command, and there we go. And let's take a look and see what's generated. And if you look, you can see search message, within it was the response message, and within the response message was our from enum. And notice how it's scoped. So for Go, the names are just getting super longer classes. But at the end of the day, you don't have to worry about the details. At least you know that how it works. Here is our search request, and before we just simply had search request, camel case. Now we have an underscore between it, so that didn't change much. So if we go back to our code, if we go and we do this, of course we'll do go build, well install, and we'll install our updated model. And if we go to our code, and of course if we try to do go run, and this is going to fail because we do not have search request anymore, camel case. What we have is search underscore request and underscore response, and this guy is search underscore response underscore form. So this is that, and oh, so response, there we go, current. All right, so the value is no longer scoped to the from as it was before, or it was like from underscore thing current. It's just simply on the response now. Okay, and so everything should work the same way. And so if we run this, you can see it still works just as before. All the field name, the crazy field name, doesn't get bubbled up in the display. Okay, so I hope that sort of give you a better feel for Protobuffer. In the next video, part 4, what we'll do is now that we know how to write Protobuffer files and messages and use them, what we'll do is actually see if encoding a message in Protobuf is more efficient than encoding it with the gob that we use in part 1. That's what we want to see. And then once we sort of justify why we're using Protobuffer, then we move on to the other parts. Now, there's a little caveat. As we move forward, there's some things that we'll have to sidetrack. We'll have to sort of stop what we're doing and go after the side and do something else that will allow us to continue. Now, one way of doing, because they're prerequisite things that we need to do. So for example, I've never really covered context using the context package. But when we generate services with gRPC, it's going to use context. And if we go ahead and just start using that without covering context, then some of you who don't know context might be left behind. So we might have to say, well, when I start gRPC, I might go like, okay, let's do cover context and then the context package and then come back to gRPC. And so that's an example of where we go off on a tangent, but suddenly we sort of come back to where we left off. Another way was to say, before we do all this, let's just cover all the prerequisites. But the disadvantage there is we may not know all the things that we want to, and even if we do, just trying to cover everything up front before we get our hands wet with what we want might just not be as exciting. And so, all right, so just wanted to make that caveat. Now, I said that I'll give you my opinion. So now that we've done this, let's close this, and the code will be available in the repository. There's some other types that I didn't cover, like, for example, any and one of. And so this any is an example of how you can, in Go, we have, when we want to store any value in variable, what do we use? We use the empty interface. So this is equivalent to the empty interface. Do you have a way of how you use it where you have to test to see if what type of value is stored there and so on? In my opinion, the Go empty interface is much easier to use if you want to use a value, but of course you're not going to get it from Protobuf. But the ability to be able to say that, oh, I have a field like details in which I can store either a string or an int, just relates to possible brittle code. As you see, you have to always check to see if detail has this particular value. And if it has it, deal with it one way. Else, if it has something else, deal with it another way. I wouldn't recommend doing that. I think that you should start to stay away from things like that. Another thing that Go Protobuf allows, which is this one of. And one of is a way to basically reuse the same block of memory for a number of different things. And you can sort of think of it as a union. And I, again, would, because of how you have to use it and the hoops you have to jump through to make sure you use it properly, I would not recommend you use things like one of. Of course, if your application requires it and you have to do it, then by all means, go right ahead. But I don't use features of a language just because they're there. Like, for example, Go has, labels where you can jump from here, or you can say, continue to this from this label location. I do not use those things because in all my experience of programming, only when I've done embedded programming in C and C++, and really C, when I write like C with assembly language, embedded and so on, I've had to use things like labels. And so it's best to stay away from some of those trickier parts of the languages, because you can end up writing unmaintainable code or really complex code. Always try to make sure that all your code say what it's doing, and people should be able to read it. You should be able to look at it and understand it, even if it means writing a little bit more code. Just trying to write something that appears might look cute and all this other stuff. But I know I'm lecturing right now, but it's my opinion. And so I wanted to give you why I'm not really looking into stuff like playing or showing you one of, but I want you to know it's there for you to use. So there we go. I think that's enough of Protobuf for us to be able to play with it now to encode messages and decode messages, and then compare it to the other things we've used. And then following that, we'll start talking about gRPC, which is right there. And I'll be posting the complete Go course pretty soon as a thank you for all you who stuck with me and still spread the word and subscribe. If you haven't subscribed, please subscribe. And of course, if you can, get other people to subscribe. Take care. Bye.